Hello, welcome to this episode where we shall be exploring more data captured by the James Webb Space Telescope. So in this case, if you look at this picture, I got it from Wikipedia, from Google. You must have been familiar with this picture. It was among the first that were released by the James Webb Space Telescope last year. So we're going to learn how to process it by ourselves to produce the same result as NASA. So to download the data, I have explained it before. You come over to the master archive. This is SMARTS. The code is SMACS 07. Just type SMACS 0723. It will come out. So I have taught you how to navigate from the beginning, from the advanced search all the way to this part. So if you haven't seen that, if you haven't known it now, I would suggest that you watch my videos on how to navigate the master archive. So if you look very carefully, you would see the files. There are 6 of them. However, it appeared in pairs. Okay, so we're going to see why it is like that when we start processing it. So you can go ahead to download it, but I want to let you know that this file is quite large. So if you highlight all of them and put them in a basket, like what I'm doing right now, I'm taking all of them, selecting all of them, and put them in a basket. It will take forever. It will take forever for, if you click on this basket right now, it will take forever for this website to retrieve all the data. So the best thing is to do it one by one, okay? Just do it one by one so that as this one is downloading another one, you're now retrieving another one. So with that, you'll be faster in your download. So go ahead to download it. After downloading it, then for me, I have downloaded it already. So this is the see the fit files. I've extracted them from the zip, and here is my fit file. So normally you are supposed to use fit liberator to convert it from fit files to TIFF files, but because what I've told you before with images from the James Webb Space Telescope, you have to align them first. If you even observe from here, you see the first three 1.6, 1.7, 1.6, at least 1.6 on the average, are bigger in size than the last three filters. So, but when you align them, they become the same size. But that is not even the case. You make them to be the same because they do not have the same scale. So, and the software we use to do that is the Siri. So I'm going to open this in Siri so that we can register the images. And right now I'm in Siri. To load the folder, you come over to here. You check on your downloads. So this is my SMACS. This is the current folder, and this is the images here. So you click on open. So the next thing you do is come over here. You highlight all of them. Then you add. So once it is added, please untick this. Then you just give it a name. You can give it any name of your choice. I like to give it align. Align. Then you first of all convert it to sequence. So you convert. So give it some time for Siri to put it in a sequence. So it has finished. If you want to see the sequence in the directory, come over here. You see that Siri has converted the 6 filters to this. And if you observe also that it has also reduced the sizes because of that. So the next thing we're going to do is to first of all let us have a preview of the image. You click on auto stretch. And if you observe that Siri is using the first one as the reference, so that is automatic. That is by default. So if you come over here, you would see the 6 images. And here, this one will be used as your reference image for the registration. So let us use it. Come over to registration. It's in global style alignment. So it just comes straight here. Click on convert. I like to change this to REG. You can, if you want to leave it at R, no problem. So you click on go register and allow Siri to register the images. It is matching the the stars in the 6 filters. Please remember that Siri works offline. You don't need to connect your computer to the internet. If you observe that my internet is not connected, so my Wi-Fi is not connected, so it works without internet. So Siri has finished aligning my images, and if you observe very well, you would see that two of them failed. Two of the images failed. It only registered 1, 2, 3, and 5. That means 4 and 6 failed. So like I have told you before, you have to create a table. You have to create a table to three columns. So this says reference image. This is registered, not registered. So in the first one, we use 1 as our reference. Oh, this is registered, sorry. Okay, this is registered. So from what we have there, okay, from what we have here, 1, 2, 3, and 5 registered. 1, 2, 3, and 5. And 5 registered. And here, 4 and 6 failed. So maybe let us use 6 as our reference. Let us use 6 as our reference. Again, come over here, come to sequence, change it to align the first sequence. Then we're going to use 6 as our reference, or maybe 4. Let's just use 6 now. Okay. Then register. I'll change another thing, so register. Ah, it is failing again. So in this case, 1 failed, 5 registered. Let's see it. Let's see which one failed. So in this case, the first one failed. So we 2, 3, 4, 5, 6. The first one failed. So here we might want to say let's use 4 to do it. Okay, for us not to waste our time, I have done this before and I'm going to show you my own result. I'm going to show you my own result. So this is what I got. So I used 5 to as my reference and 2 failed. I later used 4 and also 2 failed. Then I used 3. I used 3 and none of them failed. So I'm going to use 3. But on your own, you might want to try these other numbers to confirm my results. So I'm going to use 3 so that we don't waste much time. So I'm going to use 3 in this case. So let me run the process again and it's going to work. Align. Come over here. I'm going to use 3 as my reference. registration, go register. Let's watch, see what's gonna happen. And there you have it, 0 failed, 6 registered, like I told you before. For using 3 it worked. So if you come over here, I think I want to, let me just close Siri because I'm done with it now. Let me close it. So I come over here, so all of them are registered. So, and if you observe the size of these registered images is exactly as the size of the third image. So I'm going to use Fit Liberator to convert these registered images from fit files to TIFF files. So I'm not going to show that because we have been doing that before. So I'm going to just do it and show you the work. So I have used Fit Liberator to convert my fit files to TIFF files. Remember, I only did that only on the registered images, and the Fit Liberator um, has even reduced it the more. So if you observe very well, and also observe that I renamed it with the filters. Like this one, this 90 corresponds to this one, 150 corresponds to this one, and 200 corresponds to 200 right there. So that's how I renamed it when I was saving it with Fit Liberator. So the next thing is to use Photoshop to combine the images to produce beautiful image. So join me. So here is Photoshop. I'm going to import them like we normally do it before. So you highlight them, click OK. And now that the images are loaded, we have to begin by stretching them. So I'm going to start with the first one, image adjustment curves. I'm going to use curves. In the previous one, I didn't use curves, I only used levels, but here I'm going to use curves. So stretch, this is the first one, the first stretch, and then do it again, adjustment, second, still extracting them, this is the third round, I feel like I want to do it again, so uh, this is, okay, it's coming out, the data is coming out, so this is the fourth, and we have a lot of noise, so the fourth, I did it 4 times, so come over to levels, so I can remove this noise, see, so you take it all the way here. Alright, so this is okay, so do the same for the second image, image adjustment curves, that's the first one, second, third, I'll do it 4 times, and the fourth. Oh, we have a lot of noise. Then levels. It's okay. Come to the third one. Image curves. One, two, three, four. All right, levels. You move it. Okay. Come to the fourth image. One, two, three, four. Then come over to levels. Okay. Curves. One, uh-oh, two, three, and four. Then levels. Uh-oh. Okay. Then the last one. Come over here. Uh-oh. One, two, 3. Oh, I think I'll have a lot of noise already, so let's stop there. Okay, and that's it. So we highlight all of them so we can change it from grayscale uh, from, from uh, to RGB color. Don't merge. So the next thing we're going to do is to colorize the images. So the question is, what colors do we give to the filters? So to know the colors to assign, you have to come over to Google and search on the Web Telescope um, website. So this is Google. You come over to the search space, you type Web Telescope. We have used that before. So make sure your computer is connected to the internet at this time. So this is the Web Telescope website. You click on Image Gallery. Then you scroll down a little bit. You come over to here. You say we are looking. This is Galaxy. So click on Galaxy. Type Observations, Collection, First Images. Then click on Submit, and pops out. So where first deep space. Okay. Let's click on here. And here is the picture. Scroll down to the end. You see the different colors NASA gave to the image. So this is the image for the Miri filters. It has 4 filters, and this is for the NeoCam, the one we are interested in. So for the 444, it is red. This one is orange, green, green, and blue, blue. So that's the colors to assign to the different filters. So let's go straight to Photoshop. Red, orange. So the first one is gonna be, I'm sorry, this for the 444 filter is gonna be red. So go to colors. Okay. Click on colorize. Red is 0. Red is 0. This is gonna be 100. And minus 50. Come on to the second, orange. The second is orange. Click on layer, adjustment layer, saturation. Click on OK. And click on check on colorize. So orange is 30. Orange is 30. Then this says 100. And this is minus 50. Minus 50. Then make sure come over here, change it from normal to lighting. Then click on this one. This is going to be for the green, green layer, new adjustment layer, here is saturation. Yes. Okay. Green is 120. This is going to be 100. This is going to be minus 50. Okay, you come over here, change it from normal to lighting so that you can see what you're doing. Then come over to this one, the same green layer, your adjustment layer, hue and saturation. Okay. Um, Colorize. We have 120, 120, -50. Then come over here, change it. Come over here, change it from normal to lighting. Then here, this is blue. I'm sorry, blue, the adjustment layer, here saturation, and click here, and click on colorize. Blue is 200. This is, I just took, blue is also 240, but I want to just 200. 100, lighting, -50. Then here is lighting. It's coming out gradually. Then to the last one. Alright, layer, your adjustment layer, your saturation. Okay. Then you have 200 and have 100, and here it's gonna be -50. Then you change it from normal to lighting, and there you have it. I want to zoom in so that we can have a closer look at what we are doing. If you observe this picture, you would see this star right here is white, and this is also white, but our own is not looking white, although we are yet to do some other things, but we need to make that correction now. So to do that, adjust the you have to adjust the the lightness of the filters. So I want to adjust this one, 150. I made it higher. So observe. Uh, so the color is coming out gradually. You see that? So no. Okay, it's okay. It's okay. So we can now at this point flatten our images. We can flatten our images. Flatten. So the next thing is to duplicate it again so that we can apply the curves. Come over here, curves, come to this extreme, stretch it up. Let me shift this so that you can see what we're doing. So you see the picture, the objects, galaxies are getting brighter. Just gradually, okay, getting brighter. Now you come over here, stretch it backwards, stretch it backwards. Oh, I think it's okay. Then click OK. Then the next thing we need to do is to duplicate again. Duplicate again. Then you come over to selective colors. So we can add or subtract some. So we're starting from the red. We're starting from the red. So let us subtract some red. So you're doing that, see the colors when you get to. Okay, I want to check here. No, no, no. I want. Let me subtract some red colors. It's okay. You might want to check on magenta if that has any effect. Look at just one of the stars. If does it have any effect on it? Okay, it's okay. Let's leave it there. Then yellow, is it? Let's check if yellow has any effects. Oh, yellow has effect. Yeah, I can see it. So let's take it to the extreme. I like it. All right. Then you can check on green. You can check on I don't know. You can check on blue, but I think this is okay to me. So let me check on black. Go to black because I would like to make the background darker. This is it. It's okay. It's okay. It's okay. So you flatten the whole image. We are happy about the result. So afterwards, you can create another duplicate because there's one more thing I want us to do. We need to increase the brightness and the contrast. Let's increase the brightness of the galaxy, make it sparkling. See that? Get the brightness, sparkling, contrast, and this is okay. It's too bright. And that's it. And have to create another duplicate so that we can crop it, and that is all. So if you observe, there are two images here, but I'm more interested in this one, so I would like to crop this one out. Okay, if you want to save this, fine, or maybe you want to, maybe you should save the image first, and then you come back, you crop this one out, and maybe the next one you crop this one out to save this. So, but for now, I'm interested in this only, so I'm going to just come over to crop. Uh-oh, I I clicked on crop. Okay, so I'm going to adjust this, bring it all the way to here. I move this. Okay, it's okay. So enter. Then you merge, you flatten everything. So this is my image. Let me make it full screen and see. So this is how I was able to process the lensing galaxy cluster. Thanks for listening.